Well, I think that next we have the Aurorasaurus team. We're really excited to have you guys here. This is Elizabeth and Michelle and Michael. I apologize, I only have the bio for Elizabeth, so I'll tell you a little bit about Liz and maybe the rest, I'm sorry, that Michael, you can chime in and you guys can, yeah, I'm sorry, I'm stuttering. You guys can chime in a little bit and tell us how you contribute to the team as well. Liz Macdonald has her PhD in physics, focusing on space science from the University of New Hampshire. She attended the University of Washington for her undergrad, where she was introduced to the Aurora and the exciting research field of experimental space science. As a scientist at Los Alamos National Laboratory, or LANL, Liz works primarily on space weather instrument teams. For example, she is a co-investigator for NASA's Radiation Belt Storm Probes, RBSP, mission focusing on the HOPE instrument for the last several years. She's also actively involved in educational outreach efforts aimed at increasing diversity in STEM fields and communicating the beauty of science, especially the Aurora. Liz and her team are joining this month's COP call to talk about the Aurorasaurus project, which seeks to create a highly accurate, easy-to-use real-time map of confirmed Aurora sightings. So with that, I'm going to turn it over to your team. Thanks.
Hi, thank you, Dawn. Thanks for that introduction. I don't even know where you got it from, probably my website somewhere. But
Nancy sent it to me.
Okay, all right. I've just moved, so I have no idea where anything is. But I'm going to take you guys through a few slides here about the project, and then certainly jump in and ask questions. And we can talk more about how people can use our platform and our idea, and we're also very interested in getting feedback from you as teachers about how this could be an informal science education project that is very interdisciplinary, advances and education and also computer science interests. So I'm going to try to share the screen now.
And Liz, I'm going to jump in here. This is Angie real quick. I'm going to jump in here too. And Lynn Powers has some things that she's looked at too, as far as classroom connection too, as one of the members of our community looking at your site, just so that you know.
Yes. Yep. Yeah. And certainly I'm excited to hear what you think of it. Can you guys see those slides? A slide. Okay, cool. Yeah. You're all, I've never done this kind of video chat before, so I feel very like I'm in the middle of the Brady Bunch right now, but it's kind of fun. So the name of our project and our website is aurorasaurus.org. Kind of a subtitle there is Citizen Scientists Experiencing Extremes of Space Weather. I'm excited you all are up on space weather, and I'll assume that some of what I'm talking about is familiar, but please stop me if I've missed things. Our team spans from New Mexico to Maryland and a lot of places in between. We also have a computer science professor, Andrea Tapia from Penn State University, on the team. And we have received some funding from a variety of sources. And our primary funding right now is coming from the National Science Foundation. Let's see. So what this is geared at is giving people an easier way to, and more accurate way to understand how to see the northern lights. And so what happens right now is that the sun does something and everyone gets very excited, and then we don't know when that's going to hit the earth and how strong that's going to hit the earth. And so as a scientist, I'm interested in how I think we have a big opportunity for improving these communications more accurately. The slide here shows the figure of some of the models that we put out to the public. Basically, there was, I started to have this idea in 2011. There was a really large event that started at the sun, hit the Earth even sooner, way sooner than was predicted. Currently, we have one model of the propagation of coronal mass ejections from the sun to the Earth. And this one model has a lot of uncertainty. The uncertainty is plus or minus 7 hours. So what that really means is that it could be dark and it could be perfect for viewing here in Maryland, or it could be perfect for viewing, you know, in Japan or somewhere on the other side of the globe. And we often, I don't think, communicate very clearly between the scientists and the public. So we're trying to improve some of that, and one way to do that is by including social media. So there's a lot of interest in the aurora. There was a really large storm in 2011 that happened, and it coincided with nightfall across the eastern seaboard. So the aurora was way more visible at lower latitudes than usual. And it came into where many more populated areas. It happened to be red, which means that it occurs at a higher altitude, which means that it can even be seen further away. And so the next day after that happened, there were tons of news stories. And this was the day that I joined Twitter. And people on Twitter actually were reporting that they had seen the aurora, and for almost the first time that I know of. And so basically our project is to take these kinds of observations and put them on a map and use the internet to connect us better, to let people know that, hey, somebody in your state was seeing aurora 5 minutes ago. Maybe you should go outside and look. And so we have a prototype system that's built on our website right now, and it doesn't do all of that, but that's what we are aiming for it to do. I'm going to stop and see if that made some sense, and I'll go into more detail, but please ask questions if you have any.
Liz, would it be possible for you to send us these slides so that we can post them as well?
Yeah, I just sent them to Nancy and Ricky and Dawn, I think. So I don't have all the emails, so you guys can forward them, please.
Fantastic. Thanks so much.
Yeah. So this is just an overview from a talk that I gave a little while ago. So it's kind of thrown together. It's not specifically aimed at teachers, but, you know, I think it covers, you know, introduces you to our project. So I'm going to mostly try to talk beyond the slide. So anyway, the project started as this interdisciplinary idea, and I'll talk more about that. But basically, space science has this problem, which is that we're really cool, but we're really data starved. And we can't improve a lot of our forecasting until we have more data, and we're covering such a large area that it's difficult to be very accurate. Citizen science is a growing field that has a lot of opportunity to help solve some of these problems, and computer science is the field that merges those two in ways that hopefully help them connect. So this next slide shows a snapshot from our website. Basically, you all know about the solar maximum. This is the first solar maximum with social media. So social media like Facebook and Twitter and Pinterest and Instagram and all of these other sites where people can share data, and they can publicly or privately share what's going on in their lives. For instance, that they just went outside and saw this amazing aurora. And so these sites did not exist in the last solar maximum. So since 2011, we've been building up for this solar maximum to try to capture, using the current technology, how we can link people with it. This may not be the type of system that exists in the next solar maximum, but for right now, this is something that we can use to capture the public's interest when there are more geomagnetic storms that cause the northern lights to be visible at lower latitudes.
I'm sorry, Lynn?
Please go ahead.
We're not seeing the next slide.
Okay, what are you seeing?
It's the same slide as the first one. It hasn't changed.
Oh, okay. Do you see it now?
Yes.
Oh, okay. I'm sorry. Thanks.
That's okay.
You didn't miss much. This was the one that is all like data heavy and hard to understand. All right, this is the cool slide. Can you see it full screen? Is it okay?
Yes, it is. Thank you.
Okay, great. Thank you very much. So what our website currently looks like, and we are in the middle of revamping this, but on the left-hand side, there's some information where you can report the Northern Lights, and you can also change the legend on the map. The map shows human observations, these citizen science reports that have come directly in from our website. It also shows tweets from this huge fire hose of information that is Twitter. And some of those tweets have a location, and some of that, and it's only showing tweets that are about the Northern Lights and putting those on the map as a data source, along with a couple of other things that if you're familiar with how there are more resources to predict the visibility of the Northern Lights, and basically they put ovals on the globe. And so the pink and the purple kind of regions on this map are the ovals on that globe. If you go to the real page, you can move the map around. You can see what the auroral oval is currently forecast to look like. It's probably pretty small today. And you can see also where it's predicted to be in 1 hour. That's, I think, the purple region, in addition to the pink, which is where it currently is. So this is just a snapshot from a past time when we had our prototype running, and it was capturing a time of high activity. All you teachers in anywhere, you know, in the northern states, the U.S.-Canadian border, you can see that the aurora was actually overhead at 11 p.m. on September 30th, 2012. And there have been several other events like this. And so our website doesn't currently allow you to log in and be notified of it, but you can follow the Facebook page, and we're basically trying to respond to as many of these events as possible. And you can also follow this page in real time. Let me see. So
Liz, this is Andy. So the purple is where the aurora actually was, or the pink is where the aurora actually is, and the purple is where people can have seen it. Is that, did I get that right?
Not quite. The pink is where it currently is as an estimate, and the purple is where it will be in 1 hour, also as an estimate.
Thank you. That was helpful.
Another product that we are developing, and I'm looking for a postdoc right now to work on this aspect, is how to combine the noisy human inputs with these estimates, the pink and the purple regions, to make something that is actually much more dynamic and much more representative of what the aurora actually does in real time. So on the website, you can enter your location, and you can click the box, I saw the aurora, or I did not see the aurora. And then there will be another form that pops up and asks you relatively simple questions about what color it was, how much it was moving, and things like that about the aurora, which are displayed on the map with their own icon. So I'm going to go to the next page. The next page is similar. It just, I added a little bit of information about Twitter in case you're not a Twitter user yet. The reason that you should be a Twitter user is because it's one of the top websites in the world, and it's a source of scientific data in this case. There's 340 million tweets per day, and during a large geomagnetic storm, there could be 1,000 or 10,000 or some huge number of tweets about the aurora, depending on, you know, if we really got a really large event. But there can easily be hundreds to 1,000 tweets about the aurora, and those can be displayed. You can try to pick out the location from those tweets and where they were sent from, and then those can also be displayed on the map. Some of those are not really true sightings. Some of them are sharing of information about the Northern Lights. So this slide shows in the lower right-hand, left-hand corner, if you clicked on a tweet, it shows you the text of that tweet, and in that case, that person was sharing information from another page about where the aurora currently was, if that makes sense. So you can just click on the page and look at the tweets. We can go try this later if you want.
Liz, we have a couple questions on the chat box. What is the, Maggie's wanting to know about the peaks in the purple that go up through the pink.
Oh, yeah, that's a bug. It's no longer there. So it's like coding-wise, it's hard to, you have to like connect these polygons to make this like oval shape. If you're looking at me like gesturing in my video box here. So that was just an early bug that we weren't connecting these like polygon rectangles right. And this site was basically built with a computer science grad student and postdoc, couple students and a postdoc. So it no longer, we fixed that bug, but in these old slides, that's still there. So it's meant to be a smooth line, if that answers your question. What else is in the chat box? I have my laptop screen. I can't quite see everything here.
Sally wanted to know what the Twitter name is.
Oh, that's a good question. So we actually don't have, and we should have, our own Aurorasaurus Twitter page. We have my Twitter page, which is called Spacey Liz, with a Y, Spacey Liz. And I tweet about space weather and other things. So that's not exactly the best practice for how to get your page out there. So, and there's someone else whose name is Aurora, who has Aurorasaurus as a page. So I still need to sign up for that and get that going. So I'm just giving you the current status on what works here, and a lot of this we're in the process of improving. We have a professional software development company on contract right now to be implementing a lot of these kinds of changes, and the rest of the team are working on the content. This is a really great project that has become a passion of ours over the last couple of years, and it's great because it's exciting and it's new, it's totally new, but there's always more to do than you can actually do, especially when you're trying to do it on a small, kind of trying to get it off the ground. And so we've now got a big project, bigger project, but we're still working on some aspects of that. So let me see.
And Liz,
Yeah.
Can you get to the Twitter site through the website?
You can, so there isn't really a Twitter site. There's my Twitter page, and if you go to our website, you can retweet it and share it yourself. So if you have a Twitter account, you can share it and tweet about it. That's how Twitter works. It's basically like people share things about all kinds of what interests them. So, yeah.
Thank you.
Okay. All right. And I have that information on the last, some of that information, my Twitter handle on the last page, last slide of this presentation that you will be getting, along with our Facebook page, which is good for the real-time interactions with users. So right now we have about 1,000 Facebook followers, which is actually not that high for space weather pages, but we're growing, and we're interested in people who might want to contribute, especially on Facebook, or get involved with this. So definitely, if you have any insights and ways you might want to contribute, we definitely can talk about that. Just to get through the presentation here, just to show you, the Google map also shows weather, and if you've ever tried to see the aurora, clouds are really critical. So it's got, from Google, it's got like the satellite layer with some weather showing where the clouds currently are. So that's helpful as well. And in some cases, when we're seeing a lot of people tweeting about the aurora, like the close-up on this page, you see that they're not tweeting from the areas that had clouds. They're tweeting from the clearer areas. If I had a pointer, I could point to that on the slide, but I don't think I can do that. So I'm going to go on. Okay, so this is a snapshot of our Facebook page. I just want to mention here that in case you weren't aware, there's a whole field of computer science called human-computer interactions and information science and technology that I was not aware of at all, but really focuses on how people interact with technology. And so that might be something else that if you have students who are interested in that side of it, that's something else they can look into and study those kinds of questions. The tweets correlate with KP. I don't know how many of you know what KP is. It's an index of auroral activity, and we can definitely see a sharp rise in tweets when KP rises above about 4. I'm not going to go into that too much right now, but just to tell you that's something that we see and we're very interested in validating further. So I've listed kind of some of our future, actually current plans, what we're currently doing. We're currently enhancing the website so that you can log in and then be notified by email or text message, and also possibly by Twitter direct mail through that. But and then let's see, and then so that it will display a more dynamic, real-time auroral oval. And we're also building in educational resources to this site so that people can learn. And we want it to be a lot lower jargon than a lot of the space weather resources that are out there. So if you have any feedback on that, other than everything is jargon, but things that you found that are good, easy ways to communicate these kinds of things with people, I'd be all ears about that as well. Some of the educational elements that are involved with the page are content that Michael and Michelle are building right now, and they're looking to resources that exist on the web, and we're building our own specifically for this application so that we can teach people how to understand what is an aurora, what they've really seen, how you track a storm. Sorry, that's my phone in the background. Let's see, what these patterns in the aurora mean. We're also going to have people try to help us find the real tweets out of the sort of noisy list of a lot of tweets that you could get. And we're interested in how an activity that people can do to estimate the height of the aurora and connect that to the layers in the atmosphere where the aurora occurs and the colors. So we're interested in that, we're building that right now. I don't know if we want to go into that more possibly in our discussion, because maybe Lynn has some great feedback on that. There's my contact info along with my I'm now at NASA, Goddard, and so I missed updating this last slide, but my Gmail address is on there, so you can still get me there. And Michelle, Michael, do you have anything you want to add? There's one more thing, which is actually, I'm plugging Michelle's Cafe Scientifique network here on this slide. As a scientist, I got to talk to teenagers about what I do, and Michelle has a network throughout New Mexico and actually throughout the country that is expanding these science cafes for teens. So I thought I'd mention that too. Michelle, maybe you want to add more, or maybe not. I can't see. Have I? I don't know how I quit sharing my slides.
So go to the top. Are you on a Mac, Liz?
Yeah.
Okay, go to the top gray bar, and there should be a drop down. You should see your controls. There you go. You found it.
Okay. Thank you.
That was so amazing. All right. Anybody else from the Aurorasaurus team want to add in there?
So maybe we just want to hear from Lynn and hear from the rest of you guys about what ways that you might be interested in using this, or what, how we can get people interested in this.
That sounds great. Thank you so much, Liz. That's really cool. I'd like to know more about it. Maybe we can meet at Goddard now that you're in our neck of the woods too.
Yeah, I was just at APL last week.
Oh, cool.
Busy. Yeah.
So Lynn, do you want to tell us how you use it?
You want me to show you my slides real quick?
That'd be great.
Okay. I'm going to share something with you first.
Oh, I love that slide.
Please post that on the Wikio. I want to put that on my Facebook page, please.
Okay, will do. Now,
Definitely, Dimitri. Dimitri says that would be a great classroom poster. I agree.
so let me show this. Can you guys all see that now?
I can see it.
The blue Aurorasaurus?
No, we just still see your paper or your poster, Lynn.
Oh gosh.
It's
okay. Hang on. Hang on. Talk about technical difficulties.
While you're working on that, I was going to say anybody can join our Facebook page. I'm pretty sure. That was a question on the chat. I'm catching up.
Yeah, you can't. So when you share your screen, you can't see the chat, Liz. So yeah, that's the one downfall of this platform.
Okay, now can you see that?
Yeah.
Yes.
It says Aurorasaurus.
Yes.
So
Good
I'm
job,
going to
Lynn.
run through. I know. I'm going to run through these quick because Liz went through a lot of the information that I have on here, and then maybe it might spur some other questions for you guys. As we know, the aurora is caused by the solar wind, the charged particles that are coming to us from the sun and how they interact with our magnetic field. And I really like this graphic.
Lovely.
It shows, you were talking about the red,
Nice.
and it shows where the red is. It shows where the colors are. And there was a real cool picture that was put on Facebook the other day from, it's been about a month now, from the ISS. Rick's up there right now, and he's been taking a lot of really cool pictures. And the colors come from the spectrum, and this kind of shows what the different wavelengths and what the interactions with our atmosphere are that cause those colors. There are certain days that we can see it, and so we're right in prime time. It's right around the equinoxes, and the KP levels, we can see that they come down to certain levels. So if you're down south, if you hear that it's a real high KP index, then you know that you've got to go outside. The graphic on top, it talks about how many typically would you see of an aurora during a year. And the picture on the bottom, it has A, B, and C. Those are people at different latitudes looking at an aurora. So C is right under it, B it's at an angle, and A is pretty far away. And those correspond with the pictures that you see up there above you.
Cool.
These are beautiful slides.
Yeah.
And so here are some other ones. And let me see if this will play for me.
Do you know what date in 2011 that was?
The video that's playing right now is from a couple weeks ago. The date from the 2011, I can get that. That's a friend of mine, he took that picture.
Okay, thanks.
Wow.
And if you've never seen aurora, you don't realize that they move. You see pictures and they're all static. And so again, those pictures correspond, the A, B, and the C. They correspond with how close or how far away from the aurora that you are, types of things that you will see. You'll see the curtains, you'll see the columns. Is that working for you guys? Can you guys see him waving?
Yeah, it's beautiful. I think we all need a field trip.
I know.
Yes, count me in. We don't get to see this in Texas. I'm ready to come up north for some of this.
It looks like there were a lot of people who got out to see it recently. Was that some sort of group?
I've got for the PowerPoint, I just posted it on the Wigio, but Liz, we'll send you a copy of this too. I have all the credits for all the pictures in the notes for the PowerPoint that I put up.
Great, thanks.
That goes on for another minute. It was one of the shorter ones that they had, but I had to show that to you. So one thing that I learned, we are lucky we get a lot of auroras up here. Unfortunately, most of the time it's cloudy. One of the guys here, he has taught me that the best thing to do is before you go to bed at night, you check these different sources, because I used to check it in the morning and go, oh my gosh, I missed it again. So I go to spaceweather.com. On spaceweather.com, they have quite a few different sources there. We talked a little bit about the KP index, about the Aurora oval, and I've inserted a picture from an event that was a couple weeks ago. I also like this website. It has everything in one place, because when we have an event, that helps the radio waves for the ham radio operators, and so they have a lot of good resources and everything all in one spot. I also like the Ovation. These are the two models. These are from the same event. And you can see how the predictions are. The one from Space Weather, it has an arrow. It points away from midnight here, and it always points towards the sun, towards the noon. And the Aurora oval will rotate away from the sun, and so it dips down. So that's one reason why we get a whole bunch of them here. Here is an event that was recently. It's the same one that from the previous page. This event, I saw that and I went out. And even though it shows the purple and the pink way up in Canada, I still saw it here.
There's different kind of estimates, ways to estimate, but yeah, that's great.
And it goes back to that picture, A, B, and C.
Yeah.
I'm way out at C, and I was still able to see it. And so I did go in, and I got on. I told them where I lived. I was able to say, yes, I saw it. You can toggle and have the weather come off and on. And of course, Facebook, you're over 1,000. I'm a Facebook fan.
Great.
And the rest of the site has a lot of good information on it. And I did share this PowerPoint, like I said, on Wigio, but Liz, I'll make sure that you get a copy of it too.
Great.
That's fantastic, Lynn. Thank you so much for sharing. That's awesome. That's beautiful. And
go ahead, Don. No, go ahead.
Oh, I was going to say, does anybody have any questions for Lynn? And if not, we'll move on to Maggie's presentation. Maggie has a presentation about Aurora Alive curriculum. Does anybody have any questions for Lynn?
I have a question, which is just if you normally do this with students, or you just did it by yourself, or?
Right now I'm in the library downtown, and I'm doing an event tonight for the Science Fun Night. I do it a couple times a year. I talk about the Globe at Night, citizen science type projects, and we always talk about this. I do a lot of public outreach, and we do programs in Yellowstone. I get to go to Glacier. I'm going to Glacier this summer too and helping them up there. And when I do talk about the solar education, we always bring in why we look at it and the Aurora, and I talk about the Aurorasaurus. I learned about it about 1.5 years ago, so it's a great site. Thank you.
Thank you. That's great feedback. It hasn't changed all that much in 1.5 years, but there really will be a big change very soon that will be more powerful and more up to date. Just thanks.
Yeah, I like that I can, on my smartphone, I can go to the website. It's not very user-friendly. It doesn't, go red so I can see it at night. But I was at a star party, and I was talking to someone, and behind him, I could start to see the Aurora. Grabbed my phone and got on and posted that I saw it. So I enjoy it.
Great.
Awesome, Lynn. Thank you. I'm sorry I interrupted you, Liz.
Sorry, I'm just excited. I'm really We haven't made a huge publicity push yet with this because it's been in testing for a while, but we will, eventually. So.
Thank you.
Thanks. And next up is Maggie. Maggie's going to share with us Aurora Alive curriculum.
Well, I don't have a presentation. I have to share with you that I don't have a presentation, so I don't think I'll have any technical difficulties today.
That's it, Maggie. You're done. No presentation. No.
In fact, my technical difficulties came before this when I was trying to upload the files to our Wigio site, and it would not accept my PDF files from Aurora Alive, so I have them on my desktop, but I don't think I'm going to share them. I will, not right now, but I will share them, after we're done talking, and I can share them then. I got interested in Aurora Alive because the people who created that program came down to Hawaii and worked on a program with us down here called Volcanoes Alive. And it was the first time that I actually thought about how my Indigenous students learn, how my Hawaiian students learn, and if they learn differently. So in working with the individuals from Aurora Alive, I became aware of different, multiple intelligences and how best to develop activities to address my students. So through Volcanoes Alive that came from Aurora Alive, the same individuals, they then plugged me into Aurora Alive. And in the last few years, I've been using some of the lessons, especially because they are unique in Aurora education. One of the lessons I use is a foldable that students are given a piece of paper, and on it are the solar wind and the magnetosphere, and they fold it in, and they're able to see how the Earth is protected from the solar wind, but also how the magnetosphere is kind of drawn out by the strength of the solar wind. And having them have that in their hands and folding it out, even when I was doing it with them, they would go, wow, cool. So it was one thing to talk about it and have them see it. It's another thing for them to fold it and have it in their hands. Then after we did that activity, which is all in Unit 3, the Magnificent Sun, I do an assessment with my students called the sun. It's a watercolor of how the students believe the solar wind affects the geomagnetosphere. So they draw these and then paint a watercolor, and through looking at that and having the students explain it to me or explain it to their fellow peers, I'm able to see really how deeply they understand how the solar wind affects the magnetosphere around the planet. I also use, folk tales, legends, because here in Hawaii, we have a lot of legends about how Maui captured the sun and slowed it down. And I link that with scientific theory, just like they do with the Aurora legends. So students get to know the difference between a legend and scientific theory and hypothesis. So I'm going to move my desktop. It's called Magnificent Magnetospheres in Unit number 3 of Aurora Alive. And I have it up on my desktop now, but I can't share it with you. All of the curriculum is downloadable from Aurora Alive, and it's free. If you go to purchasing, yeah, there it is. If you go to contact or purchase, I've been in contact with them, and they're closing this out. They're having a sale on it because it was last updated. The DVD was updated in 2001, and so they're closing out all these things. So these are available for purchase, and they're really wonderful for me because I try really hard to link how my students learn and connect it with their culture. And I think this curriculum has a really good way of doing that with multiple intelligences.
That's awesome, Maggie. We had a question in the chat box, one or a couple questions. One, is it for middle school level? And the other one is there a fee or are they free?
I believe everything on the website is free, but if you want to download, the full meal deal, it's in older Mac and Windows platform, and may or may not work on the newer computers that are available. So that's why they're closing out the DVD. The curriculum itself, you can download single lessons, but you can purchase them all in one swoop, hard copies for, what is it, $24.95. Or me, I just, download, individual activities. Yeah. It's the magnificent magnetosphere watercolor that I use as a assessment. And there's the foldable. My kids really like that. And middle school, but I have found that whenever I use middle school curriculum, I can adapt it for elementary, and I can adapt it for high school. It's for everyone.
That's awesome, Maggie. Thank you. Did anybody else have questions for Maggie? Okay, thanks. Thanks so much, Maggie.
I would be. I'm sorry, Don. I'd be interested to know how other teachers have used. How have you used teaching the Auroras? So Maggie has shared and Lynn shared how these new resources could be used. But how else have you? I know many of you have.
Here I am stuttering again. I also purchased a DVD on Aurora. When I visited a fish camp up in Alaska a couple summers ago and talked to the elders about how they view Aurora and what legends were out there so I could tell my students about it. And the elders, they told me that when they were little, they were told by their parents not to whistle or make any noise while the Aurora was out there, or that the Aurora monster would get them. And I always thought that was so interesting, because why would parents tell something scary like that to their kids? And I kidded with the elder and asked him, why would they tell you something like that? Were you, just a rascal? And he said, no, it's absolutely true that there is another legend surrounding that, where the Aurora actually picks up little kids and captures them and takes them away. Then my kids, because we're in Hawaii, we will never see Aurora probably. I did purchase a DVD on Aurora, and I play it for them, and they just love it. They absolutely love it.
I guess I have one question, which is that if your kids might, like if there was a storm unfolding in real time, one thing I've thought about is that you could kind of watch the event from far away using our website. And I was wondering if you had any comments on that or might be interested in that. The timing might be odd, though, being the time zone being in Hawaii, actually. Get it wrong.
Watching, I did get the students really psyched these last couple of weeks. There was X-class flare. There was a sunspot that threw some flares out that were really strong, and I was crossing my fingers hoping that we would see something, you know, big, but we didn't. And so if we could possibly see it, you mean like in a real time? Because we do have access to the spaceweather.com and we do see the KP indexes, but
Yeah, I meant with the Aurorasaurus thing. So on our page, you can actually watch people's reports show up, and you can watch the tweets show up, as well as where the oval is moving. So interested in doing that, or?
Well, you know, I did notice that there were some tweets from Hawaii. And I'm wondering if that's not the helio, you know, up on Haleakala, if that wasn't some of my scientist friends up there. So as we start learning more as we're going into heliophysics, I think that would be very interesting. Sure, I'm always up for using technology in new ways. Sure. We're in break now, but next week.
Okay, thanks.
I'll put in an order for a CME, okay?
That would be great, Maggie. But then we'll all be traveling to see Lynn in London. Okay, did anybody else have something to share about the way that they have taught Aurora?